Section 4.3, similar figures. So we're going to talk about similar figures, and the best way I can describe it that you guys use every day is when you have a picture of something like on your phone or computer, and you move your fingers together to like enlarge it or shrink it. You guys do this on your phone all the time. And of course I'm drawing a picture right now, but I know you do that on your phone all the time where you move your pointer finger and your thumb and you make the picture bigger or smaller. Corresponding sides and corresponding angles would be, so if I were to draw two rectangles, so like this would be a corresponding angle with this, and then I could say both of the longer sides would be corresponding. So they're angles or sides that are in the same relative position of each other. Does that make sense? Okay, so what we're going to look at for the first problem is decide which triangles are similar. So you're looking at the three triangles, and this one happens to give you angle measurements, so you could decide based off of the angle measurements what two triangles are similar here. A and C. Okay, so notice A and C both have the same angles. So that would make them similar. If you did not have angle measurements to look at here, you would have to set up proportions with your side lengths. Okay, so you can't, whenever you're working it with geometric shapes, you can never just look at the picture and say that it is similar or it's congruent or whatever it is that you're determining. You can't just say because it looks like it. Like that can't ever be your answer. Does that make sense? Like you have to be able to prove it with numbers. You can't just say, oh, they're similar because they look similar. Like you have to be able to justify your answer. Okay. So for the next one, which rectangles are similar? So you're going to look at the different side lengths and try to figure out which ones have the same ratio.
J and K.
Okay. I just heard J and K. Do you guys agree?
Yeah.
So how do you go from 10 to 5? Divide by 2. So to go from 4 to 2, you would divide by 2 as well. But I can't figure out a way to go from 10 to 12 or from 5 to 12. That would get me also 2 to 5 or 4 to 5. Do you guys agree? So J and K. You could have also calculated a ratio. So you could have done like 10 over 4 and 5 over 2 and 12 over 5 to see what all of those decimals would be and to see which ones were the same. So J and K should end up both with the same. Okay. Now we're getting into word problems. So I strongly recommend that you draw a picture whenever you have a word problem. Doesn't have to be anything perfect. You don't have to measure anything. Just I recommend that you draw a picture to know exactly what you're talking about. So a picture is 10 inches wide and 8 inches tall. So maybe something like that. 8 inches tall, 10 inches wide. To display the picture on a web page, the picture must be reduced to 3.5 inches tall. So this will be 3.5, and then how wide should the picture be on the web page? So I don't know the width. So what do I do when I know 3 numbers and I'm trying to find the 4th? What do I set up? What's that kind of equation called? Starts with the P. We did them yesterday. The whole lesson yesterday. Starts with the P. Has 4 parts. You set them equal to each other. Proportion. So I'm gonna do my width over the tall measurement. So it says it's 8 inches tall and 10 inches wide. So that's what's going to go together. So 10 inches wide, 8 inches tall. And then the picture has to be reduced to 3.5 inches tall. So where's 3.5 going to go? In the bottom. And then I don't know the width. Okay, so how did I solve this yesterday? Cross multiply. So 10 times 3.5, 35, and 8 times W would be 8W. And then you divide both sides by 8. So you get W equals 4.375 or 38, and then we're talking about inches here. Okay. The next problem, a picture is 10 inches tall and 14 inches wide. So 10 inches tall, 14 inches wide. It needs to be scaled to fit 1.5 inches needs to be scaled to 1.5 inches to fit on a business card. How wide should the picture be? So it needs to go down to 1.5, and I don't know the width. So I want you to try to set up this problem and solve. All right, so if I set up this proportion, I'm going to do the same thing I did last time where I have the width over how tall it is. So I would do 14 over 10 equals W over 1.5. Then I cross multiply. So I get 21 equals 10 W and divide by 10. So W equals 2.1 and our label was inches. Okay, let's look at the next problem. Okay, a souvenir model of the pyramid over the entrance of the Louvre in Paris has faces in the shape of a triangle. Two sides are each 4 inches long and the base is 5.1 inches long. On the actual pyramid, each triangular face has two sides that are each 27.8 meters long. What is the length of the base of the actual pyramid? So we're missing this base right here. Okay, so proportions involve only how many numbers? 3 numbers and a variable, right? So 4 spots. So this case, we have 6 numbers. So we're not going to use 2 of them. Which set of numbers do I have to use to that? All right, so think about which 2 numbers do you have to use in this proportion? Kaden.
The 4 and the like the bottom one?
Yes. So I'm going to have to use that bottom number on both triangles, right? Mm-hmm. And then I would just choose one of the side numbers. So I could do like, my proportion could be 4 over 5.1. And then I need to put X on the bottom because that corresponds with 5.1. And then 27.8 would go on top. So you have to make sure you use whatever number corresponds with the side that you're missing. You have to use that. Okay, so 5.1 times 27.8 is what?
141.78.
What?
141.78.
Okay. And then 4 times X would be 4X. And then what would you do next? Divide by 4. So X would equal
35.445.
35.4, we could just say in the label is meters. Yes.
Well, since like the top, like these 2 angles are the same on both pyramids, couldn't you just take the bigger pyramid thingy, one of those numbers divided by one of the 4s, then get that answer, multiply it by the bottom number and get the same answer?
Mhm. That's essentially what we just did. Yeah. Yep. Okay. A t-shirt design includes an isosceles triangle. So first question, what is an isosceles triangle? Anybody know?
Has 7 sides.
No.
Since the top two
What?
even.
It only would have 3 sides. Yeah. So it has it's exactly what we just worked with. Isosceles triangles have 2 sides the same. All right, so these 2 triangles are examples of isosceles triangles where you have 2 sides are the same, 1 side is different. So that's what we're going to construct this. So a t-shirt design includes an isosceles triangle with the side lengths 4.5, 4.5, and 6. So this obviously is not drawn to scale, but a rough sketch. An advertisement shows an enlarged version of the triangle with 2 sides that are each 3 feet long. So 3 feet long. What is the length of the third side? So again, what side do I have to use? 6 and X, right? I have to use 6 and I have to use X.
And then you put 4.5 above the 6.
Yes.
You put 3 above the
I put 4.5 above the 6 and 3 above the X, and I cross multiply and divide. So I get 18 equals 4.5x. Divide by 4.5. And I get 4 equals x. So that would be 4 feet equals x. Okay. Your assignments is page 172 and 173. What does A mean?
All.